Hello friends, welcome to my YouTube channel, and in this video we are going to cover introduction about LangChain. So we will see what LangChain does and why do we need it, and we will also see a small hello world example in the end. So let's start. What is LangChain? So let's say you are building your own ChatGPT like app or any app that you want LLM to perform. For that, if you want to integrate LLM, then you will take an LLM, you will send a prompt, and you will get a response, right? So basically, while working with the LLM, this is what LLM does, right? It takes a prompt, it then gives you the response based on the context it has due to its training or the context that you provide in its prompt, and it gives you the output in the text format. So like if you have worked on ChatGPT UI and maybe using Copilot or any other client, then you will see like whenever you give a prompt, it generates you a text output, right? But as you have seen, like in ChatGPT, if you have logged in, then it will store your history, right? It will stores all your historical conversations. So it takes context from those also. But if you will use it ChatGPT like a guest account, like without logging in, you will see it doesn't remember any of your past conversations. Like you will not see any history in the sidebar, right? Like just observe that. So in those cases, whenever you ask a question, it just answers it from the scratch, like from the previous training or from the prompt that you have provided to the LLM. But in the case if you have logged in, it takes the context from all the historical conversations as well. So something is happening there, right? So to make the same setup here, you have to remember you have to configure your app to remember all the previous conversations as well. So let's say if a user is chatting on something, for example, let's say we are making a chatbot on an e-commerce website. So let's say a user has requested for the return of an item. So in case if the LLM or you don't have a state that stores historical conversations, whenever a user comes back to your chatbot again, he or she will have to start again, right? Because your LLM or your app doesn't remember the previous conversations. So they don't know each time user logs in what the user is talking about. So it will be hectic for them, right? Like they have to start again and again and maybe getting the same answers, and it will be like very difficult for them. So to make it a successful attempt, you have to remember the previous conversations, and you have to write your code in your application in the client that is using the LLM model to remember all the previous conversations and pass them as a context when passing the prompt to the LLM. Then you want to call the APIs as well, right? So you have to call the LLM APIs, configure it based on different parameters, and pass the prompt to it, right? And you want it to search the web, and you want multi-step reasoning. So you want all these functionality for you want all LLM to perform all these functionality, right? Because based on that only LLM will give you a proper response. So you have to write all the boilerplate code to handle all these things, and it will become hectic as soon as the app grows. It will become hectic, and it will become difficult to maintain it. So therefore, exactly here the LangChain comes in. So LangChain is a framework designed to help you build applications powered by large language models in a structured way. So language provides you building blocks, so you don't have to write everything from the scratch. You have to just use those building blocks and use them to build your agent. So basically, LangChain provides you prompt templates. These are basically different types of templates that LangChain provides, and you can use them to provide different types of prompts to LLM. I'll create a separate video on prompt templates. I'll create next video on this. Then we will be covering this in more details. Similarly, LangChain provides chains, memory, agents, parsers, loaders. So if I explain all of them in one line, chains are basically when a model responds, sometimes you don't want to output it as it is to the user, right? So you have to maybe parse the response. Maybe you want LLM to send your response in a structured format, like in a proper JSON, or maybe in some other format. You want LLM to respond in a particular format only, right? So you have to change that response, like get the response from LLM, then parse it using a parser, and do things like that. So basically, chains that LangChain provides help you do the same. Like they chain different outputs. So LLM, the output of the previous function goes as an input of the next function, and so on. So this is what called chaining in the LangChain. Then there is memory and agents. So basically, agents are the agents that helps you to talk to LLM, and get the output from it. Memory is doing the same thing. If you want to remember the previous conversations, or you want to remember the history, and you want to use it to provide context to LLM, whenever a prompt is getting passed to it, you use memory. Then there are parsers and loaders. Parsers, like if you want your LLM to return the response in a specific format, you use parsers. And loaders are used when you want to load the data from a file, from a web, from DB, or anything you want, right? So for those purposes, loaders are used. So we will be covering all of them in detail in a separate video. This is just the introduction video about the LangChain. So basically here, LLM is the brain, like it does all the raw processing, right? Whatever context, prompt, or whatever thing you have, you passed it to a LLM. It does processing on it. It analyzes that, and LangChain is a system that connects everything together. So whenever an LLM returns a response, LangChain performs all the different operations that are needed to provide you a proper output. So at the simplest level, if you will see, a user will write a prompt. Prompt will be passed to the LLM, and then LLM will give you the response, right? But in real apps, like this is the simple behavior that you have seen, like in ChatGPT UI and all those things. But in the app, if you are building a proper app, then user will provide the prompt. It will pass through a chain. It will go through LLM. LLM might ask you to trigger different types of tools if tools are there and they are needed to provide the response to that query. Then it may be getting stored in the memory to remember the historical conversations, and then finally the response will come to the user. So this is like a real app, right? This is just a simple flow, like just triggering an LLM, getting a response from it, and forget everything. But if you want to create a real agent, a real app, then you have to take care about all these things, because without storing historical conversations, in many cases, you won't be able to build a real world app. So this is usually the flow in this real world scenario, and we will see this as an example. We'll also build a small agent in further in the videos. So what will happen without LangChain? Let's understand that. Let's say you are writing a code that sends a prompt to an API and gets a response. So what if your app needs memory? What if it needs to call multiple APIs? What if it needs step-by-step reasoning? So for all these things, you have to start writing code, and you have to do manage all these things manually, right? So you will be writing custom logic for chaining calls, like if LLM gives a response, then maybe call the API, then get the response, again pass it to LLM, or whatever you want to do. You have to write custom logic for chaining all this. Then you have to manage conversation history yourself, right? You have to whatever LLM is responding, if you want that context to be remembered by LLM, you have to store that somewhere, right? And you have to pass it again whenever the next prompt is passed by the user. You have to maintain the session as well, like for multiple users, different conversation history will be there, right? It's not like for a user you can pass conversation history of another user, right? So you have to maintain sessions, you have to maintain history for different users in a different session, and all those things. For all those things you will have to manage on your own. And you have to format the prompts again and again, like based on the history and everything. You have to format prompts also again and again based on the context and everything. So this will quickly become hard to maintain. So as your apps will scale, or the more number of users will come, this will become difficult to maintain. So LangChain provides you a structure here. So it gives you prompt templates, so you don't have to repeat yourself. So in the template, it's just a template, and there are very many different variables you can put. So based on the variables, you can just change the prompt. Template will remain same. So you don't have to write the template again and again. You just create a template, and each time you pass a prompt to an LLM, you just pass different values to the variables that are present in the template, and it will work for different types of prompt. We will see this like in a demo in the next video. So it also gives you chains. You can connect multiple steps. So you can say, like, after the prompt is ready, like after you create the prompt, you can just put it in a chain, and after the prompt is ready, the output of that prompt template will be passed to LLM. LLM will provide the response. Then maybe if you want the response in a particular structure, in a JSON format or in some proper format, then you can add a parser to the chain. For example, prompt template's output will be passing to the LLM. LLM will provide a response in some, let's say, in generic response. Then it will be passed to the parser. Parser will make sure that LLM is providing the final response in a proper format, and finally it will come to you. So all these you just have to create a chain. You don't have to write boilerplate code for this in LangChain. So it also gives you memory and agents. which can help you to remember the conversation and can decide what actions to take next. All these things we will see in a demo and in the further videos. So instead of writing everything manually, you have to focus on building the logic of your applications. So this is about LangChain. I hope this is clear. If not, you can just visit the official docs of the LangChain. LangChain docs are like really good. You can just go through them one by one, and they are like really easy to go through. I will be covering most of the part of the docs in the videos. Like I will be creating videos for all the functionalities that LangChain provide, most of them, and you can also go through the docs to make them more clear. So in this video, let's just look into the setup, how to set up a LangChain, and a small hello world example on the LangChain. So in this video, I'm also going to cover how to create a virtual environment. If you remember in the last video, I just told you to create a virtual environment, right? In this video, I will be trying to set up a virtual environment from scratch. So initially, you have to create a virtual. I will be using VENV to create a virtual environment. There are other ways also to create a virtual environment. I will be using VENV. So create a virtual environment using this is like fairly simple. Whatever Python you want to use, like Python 2 or Python 3, just use Python 3. If you're using Python 3, just use Python 3 -m VENV. So here VENV is the command. It will create a virtual environment using VENV, and the next one is the name. So I just use both of them as VENV. So I've already done this for this project. So if I show you, let's clear it first. So if I show you ls, you can see a directory named VENV is present here, right? This is because of this naming, the second name VENV I have given. So if you want to see my command, let's see that. So this is my command, Python 3 -m VENV. Because I'm using Python 3, that's why I'm using Python 3 instead of Python. If you are using Python 2, you can just use Python. So basically, you can provide whatever version of Python you want in the virtual environment, and then that Python version will be stored in that environment, and you can just work on that on top of that. So these are really helpful, because now whatever dependencies you will install, like whether through requirement txt or using the pip install, they will be stored in that virtual environment. So if you will see here in this VENV directory, you see all these include and bin directories, right? So these contains all the dependencies that are required for this project that I have been working on. So these are not getting stored globally, like it will not be there in your global memory, and whenever you will delete this directory or the project, all these things will get cleared up easily. So for different projects, now you can easily use different versions of the Python. You don't have to install everything globally, like you don't have to install different Python versions globally. You can just use whatever version you want in your virtual environment. Then after the environment is created, you will see a directory named VENV in this case, or whatever name you provide here. After that, you have to activate the virtual environment. So for that, let me deactivate it first. So this is how it looks. So next command is source VENV bin activate. So here VENV is the name that you have provided to your virtual environment. If you are providing another name, just use that name here instead of VENV. So after you run this command, you can see the environment is activated. You can see the difference, this VENV in the beginning, right? So environment is activated. In VS Code, after your environment is active, you can just go here. So right now I have already selected the environment. So there will be you might be seeing select kernel option here. So once you click on that, you will get a table here. And just remember to open your project at the root level of environment. So my environment is created in this at this level, right? You have to open your project here only. Like if you will open your project inside a directory which does not have the environment, then your VS Code will not catch it. So you have to open the project at the root level where the environment is present. After you have done that, you can just go here, select your environment. The name will be here, and the Python version will be here, and you can just select that, and that's all. Now you can just do pip install to install your dependency, and then run your code. So the next step is obviously to install all your dependencies. So if you are not using a requirement.txt file, you can just run a simple command like pip install LangChain. So whatever dependencies you want to install, you can just install using pip, or maybe you can create a requirements.txt. So in requirements.txt, if you will see, I have provided all the dependencies that I want along with their versions. So now whenever I want to install all of them, I don't have to mention each of them individually. I can just do something like this: ap3 install -r requirements.txt. Once you run this command, it will just go through your requirements.txt file. It will install all the dependencies that are mentioned here. And if you will see, all these will be installed inside a virtual environment. They will not be installed globally. They will be installed inside a virtual environment. Now, if I go back to the code, then you have to set up your env variable. As I have explained in the previous video as well, like to connect to an LLM, you have to generate an API key. So if you are using a Google Gemini model, you need a Gemini API key, or if you are using GPT models, you need a GPT OpenAI key. So I'm using Open Router. So I have generated a Open Router key, and this is the way. I've created a .env file. Let me search for it. This is the .env file. In this, I have set up a Open Router API key instead of OpenAI API key. If you have a OpenAI API key, you can work with that as well. In case you have a OpenAI API key, you have to first load your env variables using these. So these are two methods provided by the Python. So this .env finds the location of your env file, and this one loads the env file on your project. After you have done that, if you have OpenAI API key, you can initialize your model like this. Let me uncomment this part. So this is how you initialize your model. Here you will provide the model name, maybe any name. I am using GPT-4 Omni because it has because of the cheaper cost, and I'm just setting a temperature, maybe 0.7 or anything else. Because you have OpenAI API key, by default this class looks for OpenAI API key and it connects to the LLM model that you have provided here. By default it looks for OpenAI API key. But if you have Open Router API key, then you have to do something like this. In this class, these two parameters will remain same, but since you have Open Router API key, you have to change the base URL for OpenAI API, which is pointing to Open Router like this: https openrouter.ai API v1, and you have to specifically pass the Open Router API key. Since this param by default looks for OpenAI API key, and you don't have you have set it up as an env variable of Open Router API key, you have to pass this specifically. Or you can do, or you can set up, you can just get an Open Router API key and in the env variable just put a key value pair like this OpenAI API key. Then you don't have to pass this. But in case you are using another environment variable which has different name for your API key, you have to pass this explicitly. Then after you do this, you can just invoke the LLM like this. So if you will compare it with my previous video, this call looks pretty simple, right? Like you are just doing LLM invoke. After you have created your LLM, the agent, you can just choose LLM.invoke and pass the prompt here, explain AI in one sentence, and then in the response you will get the content. So if I like run this again, let me try this. So as you can see, I'm getting the output, text output. So if you will remember in the previous video, there was a long way to get this text, right? You have to go inside choices, then message, then content and everything, right? But here, because we are using LangChain, you don't have to follow that hierarchy. Let's see how the response looks like without content. Let me run it again. So as you can see, it's just content. There is lots of metadata as well, like lots of things that LangChain will provide you, metadata and everything. But as you can see, it's pretty simple than the previous one, right? Because your actual output, your text output that is provided by the LLM is directly coming as response.content. If you want things other than that, then you can look for like additional quotes, and then there is metadata and everything. You can just look into it. But if you will compare it with my previous video, the response we were getting from raw LLM APIs, you can see it's a lot simpler than that. Even calling LLM as well as getting the response from it. So this is where LangChain is helpful. Like it provides you lots of boilerplate code, and you can just call LLM like really easy, and you can just parse the output as well as get the output from the LLM in a very easy way. Same thing we have to do with the Node.js setup. So currently most of the functionalities about the agents and LangChain and LangGraph, all those things, they support Node.js and Python. These are like mostly supported languages. So similar things you have to do in the Node as well. If you are using Node.js for your LangChain setup, you have to just initialize a npm directory. If you are aware of Node.js, when you run this command, it creates a npm directory for you, and it creates a package.json and all those files where you can put your dependencies. Then after you have put all your dependencies in the package.json file, or if you want to do add them manually, install them manually, then you can do something like this: npm install LangChain, whatever dependencies you want to install, you can just install them. And you can also pass a flag called --save that will write your dependencies, whatever you are installing, in the package.json file. Then similarly, you have to create a .env file here as well, and you have to put your OpenAI API key or OpenRouter API key in the env file. Then after that, this is like very similar code similar to Python. You have to get your load your .env file. Then similar APIs are provided in Node as well. As you can see, this is like really similar code. Like you just import new chat OpenAI. You provide model, then temperature, and in case you are using OpenRouter, you have to provide the base URL as well as the API key. And similarly, llm.invoke, passing the prompt and getting the response.content. Like if you will compare the Python code as well as Node.js code, this is like exactly same. Only thing different is like this await. So in Python there is nothing like this await. Here you have to provide the await, right? Because this is an asynchronous call. So to get the response, you have to provide, if you want your code to wait here to get the response from the LLM, you have to use this await. And that is all differences here. And if you will compare this code looks exactly same. So it is really simple in both Node.js as well as in Python. But in my videos I will be using Python mostly. If you want the Node.js code for it, please let me know in my comments. After you have created a file, index.js file, and put this code there, you can just run your Node program like this: node.index.js. It will just run your program, and it will provide you the same output that you are seeing here. It will be just in JavaScript. Now, as you have set up the Python virtual environment, right, you can do the same for Node as well. So if I show you that, there is something called NVM that you can use to create a virtual environment for Node. So if you will see, I've already set it up. I'm using Mac, so it's fairly simple for me to set it up. If I do NVM ls, so as you can see, I have 3 different Node versions here. If I just highlight them, so as you can see, I have 3 different Node versions: 14, 20, and 24. And whatever you want to use for your project, you can just select that. So it's very easy with NVM to install or uninstall a node or use different node for different projects. So let's say if you want to use let me again do NVM ls. If you want to use let's say 20.20.0, then you can just say NVM use and provide the version here. Okay, so now using, as you can see, now my node is at 20.20.0. But if you are using another project, or you're working on another project in a separate tab, then you can just if I check the version here, you can see it's 24, because my default version with NVM is 24. So whenever I open a new tab or things like that, it just moves to the default version. So you can really use NVM to maintain different node versions for different projects, and it also creates a virtual environment like VNV in Python. Alright, that is all for today's video. In the next video, I will start with the prompt, different types of prompt templates provided by the LangChain, and then we will further move to all these things like chains, memory, agents, parsers, loaders, one by one, and then we will look into creating smaller agents with the help of LangChain. Let's meet in next video, and by that time, have a nice day and good luck.